Hey guys, this is Miss Mo. This is 13.4 where we talk about surface area. Surface area means the surface. Yeah. So if we're looking at this calculator, the surface area would be what's on the top, on the sides, on the bottom, but it would not be like all the junk on the inside that we can't tell. For example, the batteries would not be part of the surface area. The batteries would be on the inside of the calculator. So, surface area just means like where you would see the label on a tuna can. It means the surfaces. Okay, so first let's find the surface area of a cube. Over here on the right, the formula says SA equals 6S squared. That's because you want to find the area of one of the squares, and that's S squared. But then there's 6 faces of a cube. That's where the 6th comes from. So, this is a cube, so we're going to say 6S squared, and that's 6 times 5 squared. PEMDAS says we do the 5 squared first, so 6 times 25, and that makes 150 centimeters, and we're still on area. So area is squared. Okay, let's look at this right circular cylinder. Okay. Over here on the bottom right, it says that the formula for a cylinder is 2 pi RH plus 2 pi r squared. Okay, well, let's see here. This 3 is from the center all the way to the outside of a circle, so that's called the radius. This 11 is the up and down, so it's the height. The pi is a symbol. We keep it there. All right, let's see what we get. We get 2 pi times 3 times 11 plus 2 pi times 3 with a square. Okay, now we're going to multiply all the numbers together. 2 times 3 is 6 times 11, 66 pi. Let's keep going. Over here, PEMDAS first. PE. 3 squared, 3 times 3 is 9, times 2 is 18 with a pi on it. Okay, let's add those up. 66 plus 18 is 76, 80, 84. Keep the pi. Okay, and this is called the exact answer. If you want a decimal or an approximate, you put this in the calculator. Or say 84 times 3.14. Okay, what are our units? We're centimeters, and area is squared because it's 2-dimensional. All right, let's keep going. Part C, rectangular prism. His formula says 2HW plus 2LH plus 2WH. Okay, well, let's look at all these numbers. The 4 is the up and the down. That's the height, like a flagpole standing up in the air. The 8 is the length. But then that 7, sometimes we call it the depth, or how deep the box is, how deep the shelf is, okay. So this 7 is the D, the depth, or we can call it the width. Yeah. Okay. So we're trying to find the surface area. So they say H times W. So that's actually finding the area of this side square. And there's 2 of them, one on the left and the right. So that's why it says 2HW. So 2 times 4 times 7. Plus sign. Then it says 2LH. Well, L is the side to side, and H is the up and down. So that middle portion is finding the front rectangle and the back rectangle. Okay, now let's see the last part. It says 2WH. W is how... I think I wrote something down wrong. HWWL. I think this last one is supposed to be WL. Yeah, so over here where it says plus 2LH plus 2WH, it's supposed to be 2WL. That's supposed to be a L. Okay, so now we're going to do 2 times the W and the L. Okay, the L is how long this is. The W is how deep it is. And that means we're finding the area of this top rectangle and the rectangle on the bottom. So plus 2 times 7 times 8. Okay, and then let's multiply all these and see what we get. For the first sucker, we get 28 times 2, 56, plus 8 times 4, 8, 16, 24, 32, 64, plus 49, 56 times 2, 118. Oh gosh, it's the end of the... I'm not adding these. Okay, and then that makes... 238. 238, yay. Okay, and what are our units? Centimeters. And we're still talking about surface area. So squared, 2-dimensional. Okay, let's look at this sphere. The sphere says 4 pi r squared. So it's going to be 4 pi, and then your r is that measurement from the center to the outside of the circle. So 12 squared. Okay, now we're going to do our multiplying. So 12 squared is 144. Then times 4 is 576. And we're still centimeters squared. And that's the exact answer. If you want the approximate or the decimal, you have to put it in your calculator. Okay, let's look at E. It says a right circular cone. Well, up above, it says pi rs plus pi r squared. Pi rs plus pi r squared. Okay, we know the r is 20 because that's from the center of the circle to the outside of the circle. So we know r is 20. But what we don't know is the s. Okay, we might think that 15 is the s, but 15 is the height or the altitude or the apothem. We need to find the s, which is the slant. Okay, to find the s, we're going to use the Pythagorean theorem. So, I should see a little triangle up in here. Hey. A right triangle, to be specific. And so to find that hypotenuse, we're going to do the Pythagorean theorem that says a squared plus b squared equals c squared. where C is the hypotenuse and we don't know it. But A squared is 20 squared, B is 15, and let's add those up. 20 squared plus 15 squared is 625. Okay, then to get regular C, we do square root 625, or what times what multiplies 625. So our C is 25. Okay, that C from the Pythagorean theorem is our slant. As in, it goes in that parentheses where the S is. Okay, now we're going to multiply our numbers together. 20 times 25 is 450 pi. 20 squared is 400 with a pi. If you add those up, you get 850 pi. We're still on centimeters, and surface area is always squared. Okay, this is the exact. If you want the decimal version, you can say 850 times 3.14. Or if you have a special button, if you have a special button in your calculator, like I do, the second caret, you see it? Second caret, you can type that in. Either way, we get 2669 or 2670. Either way, whatever they want you to use. So if your homework says use 3.14, then your answer is going to be 2669. If your homework does not say anything about use 3.14 for pi, then you're going to use this 2670 as your answer, or whatever they ask you to round to. Okay, let's look at the next sucker. It says a soup can. Okay, what is the area of the paper that will be used to make the label on the can? If the paper covers the entire lateral surface area. Okay, so lateral surface area is different from regular surface area. Lateral surface area means just the part that you're going to see, or just the part that's the paper label. So let's think about this. I have a soup can. Here's my soup. Okay? And there's going to be a label. Label. Okay? Well, surface area would be the top circle, the bottom circle, and everything around the cylinder. But we only want a label that covers the entire lateral surface area. So that means the part that you can see is covered with this label. The part that you can't see is still just metal. It doesn't have a label on it. Okay, so let's see here. Surface area for a cylinder is 2 pi RH plus 2 pi R squared. Well, one of these pieces we don't need. I don't need whatever represents the area of this metal circle on top and bottom. So what represents the area of the metal circle on top and bottom? Okay, the area of a circle is pi r squared. And there's two circles, one on the top and one on the bottom as the base. So the lateral surface area is going to be the same formula, but I need to leave out one of the pieces of metal and the other piece of metal, circles on the top and bottom. And there's two of those, 2 pi r squareds. So I'm going to leave out the 2 pi r squareds and only use 2 pi rh. Okay, so I'm not using these 2 pi r squareds because those represent the circles on the top and the bottom. Okay, so let's do this. We're going to have 2 pi times, what's my r? We don't know. I don't see the word radius. And what's my h? I don't know. I don't see the word height. But I do see that this is 4 inches tall. Well, tall is another way of saying height. So 4 goes in the height. Okay? Our diameter is 4 5/8. So diameter is all the way across. Wait. And we are dividing it by 2. And it says use 3.1415 for pi. Okay, so my diameter is 4 5/8. Let's go ahead and figure out what that is as a decimal. The 4 is a 4. The 5/8 means there's a point, because it's a decimal, and then 5 divided by 8 is 0.625. Okay? But I want to find the radius. The radius is only going to be half of that. So we got to take that 4.625 and divide it by 2. And that'll give me my new radius of 2.3125. That's what you want to go in this parentheses for the r, 2.3125. And they told us to use 3.14 for pi. So we're going to have 2 parentheses 3.14159 times 2.3125, that's the r, times 4. And we get 58.12-ish. See what your homework wants you to round to. What is our units? Our units are in inches. Area is squared because it's 2-dimensional. Okay, so lateral surface area is the same thing as regular surface area. You just subtract off the pieces you don't want. So since we were talking about a paper label, paper labels don't go on the top or the bottom of a soup can. All right, let's keep going. This next sucker, it looks like a tent, and it says approximately. That means decimal. How much material is needed to make the tent illustrated in the figure to the right? Both ends and the bottom should be included. So there's nothing we subtract off. Like the tuna can, we're not, or the soup can, we're not subtracting anything off. Okay, so we're going to have to use our little brains here. Okay, for this tent, I know that the slanted side over here on the left, it's 8 long, and I need to figure out this piece because I don't know how long this is. Well, let's look. We do have a smaller triangle right here. Okay, and that smaller triangle has 3 up and down, but then on the bottom it's not 6 because the whole thing is 6. The whole thing is 6. The whole base is 6. This triangle is only half of that. So 6 divided by 2 is 3. Okay, So we know the base and the height of this triangle are 3. We need to figure out the hypotenuse. The hypotenuse we can find by doing a squared plus b squared equals c squared, as in the two sides added together with squares equals the hypotenuse that we don't know. Okay, this gives us 9 plus 9 is c squared, or c squared is 18. And if you square root that, you get 4.2-ish. Yeah. So that means on this right triangle that we just drew, this C, or this hypotenuse, is 4.24. If we're looking at this tent, this slanted piece is 4.24. Yeah. That means that that left-hand piece is 4.24. Okay? That means this slanted piece at the back is 4.24. Okay? Now let's find our surface area. Our surface area is 2 of these orange rectangles. How do we find the area of a rectangle? We say length 8 times the width 4.24. So we have 2 times length 8 times 4.24. Okay, let's see what that gives us. 8 times 4.24 times 2 is 67.84. Okay, so that's this orange rectangle on the side, the left and the right. Okay, let's find the area of this back triangle and this front triangle. Okay, well, how many are we going to have? To find area of a triangle, area of the triangle, we do 1/2 base times height. Okay, so, and there's 2 of these big bad boy triangles. There's 2 of them. So we're going to say plus 2 of those bad boy triangles. And the way we get those, the area, is we say 1/2 base times height. Okay, well, let's look at this triangle. The base is 6. The height is that up and down piece 3. Okay, let's multiply those together. 6 times 3, 18. That makes a 9. Okay, so for this 1/2 base times height, I'm not using this right triangle. I'm using this sucker that says the base is 6 and the height is 3. I'm using this huge triangle that's made up of 2 of those. Okay, now let's add what's left. Okay, we've talked about the sides of the tent, the front and the back. We have not talked about the actual base of the tent, what touches the ground. So, the area of the stuff that touches the ground is 1 rectangle. How do we find that 1 rectangle? Well, it's length times width. So we're going to say plus the length and width of this bottom yellow rectangle, okay? The length and width is this 8 that's on the left and this 6 along the front. So 8 and 6, that makes 48, and then now let's add it all together. And we get 124.84, And our units are feet. And we're talking about surface area. So feet squared. So this tent has 124.84 feet squared worth of material. Okay, let's look at the next sucker. It says right square pyramid. Okay. The formula is half of the perimeter of the pyramid times the height plus the area of the base of the pyramid. Okay, so let's see here. We know what the base of the pyramid is. The base of the pyramid is this yellow rectangle. Okay. How do we find the area of a rectangle? Length times width. What's the length and the width of this rectangle or square or whatever it is? Well, one piece is 2.5, another piece is 2.5, so all together is 5. So that means the base and the length, or the length and the width, whatever, of that yellow rectangle on the bottom is 5 times 5. Or 25. Okay, now let's look at this L. It says that's the height of each triangular face. Okay, where's our triangular face? Here he is. What is the height of that triangular face? Because it looks like the bottom is 5. But what's the up and down piece of this triangular side? And it's 8.5. Okay. So, we're going to have this 25 plus, let's see, our L is the height of each triangular base. So, our L is the 8.5. And you might be thinking, now hold up, what didn't L mean length? Yeah, these two L's are different. The L in the base means the length of the base. This L says height of each triangular face, so it's like the up and down piece. Okay, now it says perimeter of the pyramid. Okay, so the perimeter of the pyramid is all the way around the bottom. So that bottom has like a rectangle-ish looking thing, and we said, oh, it's a square, and we said it's 5 all the way around. Okay, so the perimeter of that would be 5 plus 20. Yeah. So we're going to put 20 as the perimeter of the pyramid. Then we're going to put a half in front of it. And then now let's go. I think this makes 85 plus 25. And that's 110 centimeters squared. Yeah. Okay, let's look over here on this cardboard toilet paper. Okay, it says we have toilet paper, cardboard. So, here's my cardboard toilet paper. It has a diameter of 3.96. Okay, diameters come on circles. Where's the circle? It's what it's sitting on. Or this circle on the left and the right, those are circles, okay? The diameter is all the way across, D. Okay, let's keep going. It says, and it's 4 inches tall. Okay, well, let's see here. 4 inches tall cannot be this up and down piece because we just said it was the diameter. Okay, so okay, when I say tall, I mean the height. And when I say height, I mean a cylinder sits on a base. This is the correct picture of a cylinder. Mine's sideways because it's a toilet paper roll. But cylinders, when we talk about cylinders in general, they're upright. And where the height is this long, straight piece. So our height is 4. But if I turn this cylinder on its side, the height is now that long piece. You see it? Okay. Now it says, what is the lateral surface area of the cardboard roll? Okay, we kind of already did this with this soup can. So it's saying that we are going to put toilet paper all on the outside of the roll. But does toilet paper come on the circles? No, toilet paper does not come on the base of the circles. That's hollowed out. So our surface area for a regular cylinder is 2 pi RH plus 2 pi r squared. But we're going to leave off that 2 pi r squared because those are the circle bases. And we don't care about that. All we care about is the toilet paper around it. We don't care about putting toilet paper on the bottom circle or the top circle because it's hollowed out. Okay, so let's see here. We're going to have 2 pi times my r. We don't know it. My h is 4. My r comes from the radius or the diameter divided by 2. So my radius is that 3.96 divided by 2. Or 1.98. All right. Now let's multiply all the numbers together. And I get 15.84 pi. Or if they tell you to use 3.14, it's about 49.7. And you're going to see what they want you to round to. And we are in inches, and we're still talking about area, so it's squared. So there's 49.7 square inches on this toilet paper roll. Yeah. Okay, let's look at this bottom left. We need to find the surface area. Well, let's think about this. I see a cylinder. Yep. On the bottom. And then I see half of a sphere on the top. It looks like half of a basketball. Okay, so to find the total surface area, we're going to take the cylinder surface area, and we're going to add it to half of a sphere surface area, because this is half of a sphere. The only thing is there's an overlap. Yeah, this top half of the cylinder overlaps with this bottom piece of the sphere. So this little orange shape that I just shaded in, it's counted twice. in the surface area. It's counted once because it's the top of the cylinder, and then it's counted twice because it's the bottom of this basketball. So we need to subtract off one circle. Yeah. Okay, so let's see here. Let's find the area of a cylinder. The area of the surface area of a cylinder is 2 pi RH plus 2 pi r squared. Okay. Then we're going to say plus half of a sphere. A sphere is 4 pi r squared. Okay, then we're going to subtract off one circle. So that means minus, what's the area of one circle? Just pi r squared. Okay, so we have the cylinder plus half of a semicircle minus that circular base. Okay, so let's see here. What numbers do we have? We know our H is 30. So that's the height of the cylinder. On the cylinder, we know all the way across the base is 8. That's the diameter. But to find the radius, you take the diameter and divide it by 2. And so our radius pops out to be a 4. Okay, so we're going to have 2 pi times the radius of 4 times the height of 30 plus 2 pi r squared. Our r is 4 plus 1/2 parentheses 4 pi r squared. Our r is 4. Oh goodness, this is getting crazy. I'm all the way into the next problem. Okay, minus pi r squared. My r is 4. Whew, okay. Let's do our business with the numbers, but leave the pi symbol there just for a minute. Okay, so let's do our number business. We have 2 multiplied with a 4 and a 30. That's 240. Yep. And leave the pi. So that's the surface area of the cylinder. The top circle, the bottom circle, and all the way around. Now let's work on this next one. 4 squared. You got to do PE before you multiply. So 4 squared. 16 times this 2. 32. And slap a pi on it. Okay. Then we're going to add another something. So everything we just did was for the surface area of the cylinder. So everything I just wrote was for the surface area of the cylinder. Now we're going to add on the surface area of half of a sphere. So let's multiply our numbers together. PE, you got to do the exponent first before you do anything else. So 4 squared times this 4 times 0.5. Hey, I got 32. Okay, now this last sucker. 4 squared is 16. Slap a pi on it. Minus 16. Okay, now, again, let's work with the numbers and add or subtract what we need. 240 plus 32 plus 32 minus 16. And we get 288 pi. And our dimensions are feet. It's squared because we're area and we keep multiplying 2 dimensions together, like a radius and a height. Okay, so this represents the surface area of this crazy looking thing. Yeah. And we subtracted off this middle circle that they share because that's not on the surface. That's on the inside. Surface means outside. Okay, let's look at this last example. It says 2 cubes have side lengths 4 and 3. Okay, so we got this cube of side lengths 4 and 3. It says, what is the ratio? That means either a fraction or something with a colon of their respective surface areas. Well, let's look back. How do you find the surface area of a cube? 6s squared. We're right back to where we started. All right, 6s squared. So that's 6 times, this side is 4 squared. And then you have to do the e before you multiply. PEMDAS. 4 squared. Do the e first. Times 6. So I get 96. Then for this 3 guy, we're going to have 6x squared and 6 times 3 squared. Okay, so we're going to do the e before we do the multiply. 3 squared is 9 times 6. It's 54. Okay, when it says ratio, that means put those on top of each other. Whatever you got first for the 4 centimeter, so that's 96, over 54, and then see if you can reduce it. I know you can divide them by 2. That makes 48 over 27. And then I think you can divide it by 3. Yep, 16 over 9. Hey, that's your ratio.